right, 31. Um, Here's the problem that I have to apologize to you about. I didn't talk about how to do this problem in class, although it's in your reading, so I can say, hey, if you read the book, you should get this, but I don't like to do that or make that assumption, so apologize. I had it in my notes and realized after class when a student asked me that I just got so excited about talking about other stuff in class, I didn't hit it. So here we go. Normally what we've done is this. For regression lines, to find the least squares regression line, if you're given data, we've put in our calculator, and our calculator's done the work for us to calculate the formula for regression line, and we called it y hat equals ax plus b, or sometimes mx plus b, or sometimes a plus bx. They're all equations of lines. Well, sometimes we're not given the complete set of data, or the complete list of data. We're just given what we call the summary statistics for the data, as in this case. So in this problem, we've got the mean height for American women. So for American women is 64. Standard deviation is 2.7. The mean height of the men is 69.3. Standard deviation is 2.8. And they even told us what R is. And on A, they're saying, what's the slope and intercept of the regression line of the husband's height on the wife's height for the young couples? And then it says, predict the height of the husband of a woman who's 67 inches tall, etc., etc. So basically, we're trying to find the regression line. If you give me the woman's height, I want to predict the man's height, okay, based on data. But we don't have the specific data. We have this, what we call the summary data. So for the women, which in this case is going to be my x, and the man's going to be the y. So for the women, we have their average data is x bar, or their average height. So x bar is 64. S sub x, which is the standard deviation, is 2.7. American man is 69.3. That's going to be y bar, and S sub y, standard deviation, is 2.8. And then I know the relationship, or the correlation between the two, is 0.5. So it's not super, the data's not super tightly bunched together. So what's the slope and intercept of the regression line? Well, this is actually it's on page 130 in your textbook, but I'll put the formulas right here. There's formulas for the regression line to get it. So the equation here is, I'll use the notation in the textbook. Writing it a plus bx, b, or the slope, is b is equal to r times sy over sx. So it's just a matter of substituting in these numbers that we have up here. And then the y-intercept is a, which is y bar, I shouldn't put equal signs here, but colons here, minus bx bar. Okay, so these are my formulas for the regression line when I write it in that form. So I'll have, and you don't have to memorize these ever. I will always give these formulas to you on tests and quizzes. So we'll have, oops, I didn't mean to write y hat. Didn't mean to erase that either. So we'll have, in this case, b is equal to r, 0.5, times the standard deviation of y, 2.8, over standard deviation of x, 2.7. The critical part of this is just figuring out which one is x and which one is y. And then a is y bar, the average, 69.3, minus b, whatever that number is from above, times x bar, 64. which comes from here, right? Okay, so let's do some calculating real quick. Let's do, for B, I'm going to do 2.8. Actually, I'm going to do this. 2.8 divided by 2.7 equals times 0.5. 5.185. 5.185. Okay. Oh, not 0.5185. Okay, so then that goes in here, 0.5185. And so I'm going to use that answer. See where it says answer down on the negative sign? Second answer times 64 equals, that's this right here. And so then I'm going to do 69.3 minus that answer. See, you can always have your calculator plug in the last number into the equation by just using second answer. Okay, I'm doing this because I'm trying to get you to show you how to use a calculator a little easier. And you get 36.11. So my regression equation would be y hat equals, in this case, a is the y-intercept, 36.11 plus 0.5185x. Or, in context, we're predicting men's height from women's height. So men's height, hat, equals 36.11 plus 0.5185. This is why I like doing this better, because then I don't have to remember what's x and what's y. Women's height. Okay, so there's the regression line for that. And then it says for B, draw a graph of this line between 56 and 72 inches. So here's 56, 72. Predict the height of a husband who's 67. So we're going to use the line to predict the height for 67. And plot the wife's height and predict the husband's height on your graph. So let's draw the graph of this. So in particular, we want to do 56 and 67. So when x is 56, what's y hat? And when x is 72, what's y hat? Okay, so I'm going to move this over here so you can see on my calculator what I'm doing. So we're going to do 36.11 plus 0.5185 times 56. That's going to be the male's height, 60. Oops. I don't like that it goes off like that. 0.146. And then you remember to redo that equation, remember what to push? Yeah, I'm waiting for you. Second, enter. And then you can go back and push 7.2 into there. Let you edit it. And then you get 73.442. Okay, so then that's going to allow me to go ahead and put this on here at 65 roughly and 73 roughly. This is my y. Okay, so those are my points. So my line, those aren't data points, those are just, that's my line. And then it's asked to predict it once x is 67 and put it on the graph. So if I go back, 67, boom, 70.85. So 70.85. That's my prediction. So when this is B, woman is 67 inches tall. I predict the man will be 70.85 inches tall. Okay, and I don't expect this prediction for a single couple to be very accurate. Why not? that's a good question. Why not this accurate? It's right in the middle of my data range, it seems. Well, since R is 0.5, your data is kind of spread all out here, right? It's not very tight to the line. So 67, the real data might be down here, it might be up here, it's spread out quite a bit. Okay, there you go.